Right. So this section, 6.3, is all about different types of fuel and the ways that we use those fuels. And I'm waiting for my internet to catch up. Here we go. All right. So we already talked about subsistence fuels. So again, just to remind you, these are biomass fuels. They're easily accessible. They can be gathered and found, they can be found readily, and they're gathered by hand. It does require a lot of time if you're surviving on subsistence fuels to find enough to keep, to keep your home or whatever. This is generally only used in developing countries, and is used for heating homes and cooking fuel. Some of the major, or the really the only type of subsistence fuels are wood, charcoal. Those are the two most common fuel sources that are used in developing nations. Wood is essentially free, although we can move into a tragedy of a commons scenario when we have public lands where we have a lot of trees that people are just moving into and cutting down. Um, and it causes deforestation, which leads to habitat loss. Charcoal is another tragedy of the commons because you're just wandering around finding your charcoal. And it's made by essentially heating wood under low oxygen conditions for a long time. Okay. So basically, you're turning that plant material into charcoal, essentially. You're decaying it, you're kind of speeding up the decaying process. And then peat is another type of subsistence fuel. It's basically partially decomposed organic matter. Usually it is ferns and other types of plants that are found in very wet, very acidic ecosystems like bogs and things like that. But it can really, over time, be any type of plant that is decaying. And you can see here, let's see what this picture is. Let me get rid of my camera. This just kind of shows you the, development of peat over time. And that's generally where we get a lot of the peat from. It comes from forest areas or swampy, marshy, boggy kind of areas. Okay, let's move on here to the next slide. All right, so coal formation. So coal is another type of fuel that we want to talk about. And the reason we talked about peat in the last slide is because it's sort of the first stage of coal formation. So you can see here we have trees that die, they get trapped under the ground, they're decaying still under the ground in that organic layer of soil. And then sediment keeps piling up on that layer, creating a lot of pressure as it's pushing down. And it's depleting the area of oxygen. And so that eventually peat will turn into a type of coal that is called lignite. In order of energy density and quality, our least dense amount. So, well, in other words, when I say energy density, I'm talking about the amount of energy that we get in a certain amount of coal. Lignite would be the least dense, so we're getting the less amount of energy, and it's going to be the least quality. There's a lot of water that's still in lignite, and so it lets off a lot of gas, smoke, gas, particulate matter, that sort of thing. So it creates the most air pollution. Okay, so least energy quality, most air pollution, not the best form of coal to use. The further in the ground that the coal is, it's going to be more dense, so more energy will be stored in as, a small amount or a certain amount, a fixed amount. And then it'll also be best to use for the environment. The issue is it's deeper in the ground, which means it's more expensive to mine. And so that is a problem. We're running out of the easier to find kind of forms of coal, and we're left with what's harder to find and more destructive to the ecosystem to find as well. All right. So, because there's higher energy density, like I said, that means that there's more energy released. And so, the most valuable type of coal is that anthracite coal. And so just to go over the stages again, we have peat, we have lignite, and then more sedimentation occurs and we end up with bituminous coal. This is the most widely used form of coal. When, coal use, well, we're still, using quite a bit of coal, but most of the coal that we are using is bituminous coal. And then anthracite coal, it burns really, really hot and has very little water in it. It produces a very little toxic. It does produce toxicity, it does produce air pollution, but it's very low compared to like burning a bunch of lignite or burning even a bunch of charcoal, um, or even burning that bituminous coal. And essentially, when we use coal as fuel, we're going to talk more about how that happens. So I'll kind of save that for later just to sort of speed up these notes. Okay, so let's talk about then natural gas. Natural gas comes from the decaying remains of plants and animals, and this is usually marine life. So we find a lot of natural gas in areas where the land that we have now used to be underwater. So areas like Pennsylvania, West Virginia, Ohio, Kentucky, we're finding quite a bit of natural gas. Other areas too. Anywhere where we used to have, or we can still find marine fossils, those are going to be areas that we're probably also going to find a lot of natural gas. And basically, what happens is that these plants and animals get buried under these layers of rock and they're converted into oil because of all the pressure pushing down on the materials. And that creates petroleum. And over time, that petroleum is going to give off methane gas, which is what is natural gas. And it does that over time. Natural gas, like I said, is mostly methane and it's found or trapped with on top of oil or petroleum deposits. And this forms when that oil gets trapped, like I said, under the sedimentary rock. And then that usually it has to be underneath a much harder, impermeable rock layer. If it's not under that impermeable rock layer, that methane gas will just escape naturally over time. And so when companies are going out looking for natural gas, they employ geologists because the geologists will be the ones that determine what kind of rock it is. If it's an impermeable surface, they can do scanning, they can do some drilling and determine if there's natural gas down there. Natural gas is considered the cleanest of the fossil fuels, but it does still produce air pollutants. It does still produce CO2 when it's burned. It is a fossil fuel. So it's still going, it used to be alive. So it stores a lot of carbon dioxide, and that will still go into the atmosphere. But it is much better by far compared to oil and coal. All right, so here's the fossil fuel emission levels. We can see carbon dioxide. Look how much natural gas still puts out into the atmosphere. So even when they say it's clean, the natural gas companies try to say, "Oh, it's clean energy." It's definitely not clean energy, but it is much, much cleaner than oil and coal. Um, Especially, I mean, look at coal. It's almost half as clean as coal. Um, and then, or twice as clean, I should say, as coal. And then carbon monoxide, you can still see actually it puts out more carbon monoxide than oil, but much less than coal. Nitrous oxides, which we'll talk about, we call those NOxes and SOxes. Sulfur dioxide is SOx. Nitrogen oxide, NOx, and we're going to talk about those in Unit 7. You can see that it still puts out some nitrogen oxide, but not as much as coal and oil. And then sulfur dioxide, that's a huge decline. That's almost no sulfur dioxide. It does still release some particulate matter, but look at coal. Coal's very high, and then we know what oil does to our atmosphere. So natural gas is much, much better on that in that regards. And then there's essentially no mercury, which is nice. And then it produces the problem with natural gas is it produces, or not a problem, I'm sorry. We talked about the benefits by looking at that chart. And so I think we can just go ahead and move on here. I think we've covered all of that. All right, and then we've got crude oil, and I'm going to get rid of my picture here for a minute so you can kind of take a look at what I'm talking about. Basically, crude oil is decaying organic matter that's trapped under rocks and it's compressed into oil over time. We can extract that by drilling. I think you're all very familiar with that. And so what they do, we can also recover, and that's the most common way that we get oil. We extract it by drilling. Now in Canada, they actually discovered, I don't even know if it started in Canada or maybe it started in the United States because Oklahoma was one of the first places that started using tar sands, which is basically a way that we can recover oil. Tar sands, you can see in a picture here, is a combination of clay, sand, water, and bitumen. The bitumen is what is going to be the semi-solid form of petroleum. It's not really liquid, it is a solid, but it's a very thick, sticky earth and it smells like oil. And so bitumen it's essentially, we can then transform that into the oil that we use, every day for electricity generation. But it's very much used in the southwest part of the United States. So Oklahoma, the Great Plains, Texas, and then Canada. Canada is using a lot of tar sands. It's very common for Canada to use tar sands. But we extract this and use the oil. And the problem is, you can see from this picture here, it's very water intensive. It requires us to pump a lot of water underground to then turn this bitumen into a liquidy form, and then we pump that out of the ground. So it requires an extreme amount of energy to do this. And in areas that are already like short on water, which is, the Southwest Plains, we've already talked about the Ogallala Aquifer. Using a lot of water to get oil is extremely expensive and it may not pay off in the long term. And then we have fossil fuel products. So crude oil is converted into lots of different products through the process called fractional distillation. Crude oil is burned in a furnace and vapor passes into a column where different hydrocarbons are separated based on their boiling points. This is basically how oil is made. And so then it creates these different products that you can see here. Um, and then we end up with these hydrocarbons that have lower boiling points gather at the top of the column, higher points gather at the bottom, and then we can turn all these substances into different things. That's what this fractional distillation process does at these oil refineries. And so the different hydrocarbons can be used to make all of these different items. Bitumen that we talked about before, that's the major component of asphalt for roads. So we actually do use bitumen right in blacktop. And you can imagine that's exactly what bitumen kind of smells like too, not a very friendly scent. Okay, so that's the end. This brings us to the end of 6.3. So natural gas is considered to be a better fossil fuel for the environment than coal is. So explain two environmental benefits of using natural gas. And I would also say use two drawbacks of using natural gas as a fuel. Maybe do a compare and contrast with that. Um, and again, you can find your answers for the FRQs in OneNote. And if you have any questions, make sure you reach out to me in class. Next time, we're going to be talking about distributing natural resources. That's it for now. See you guys soon.